This is the third lecture in the series on bone tissue. Our learning objectives, number one, are to describe the role of the three different bone cells, and these are osteoblast, osteoclast, and osteocytes. Osteocytes you guys have heard of already. We looked at those in a previous video when we looked at these guys here. The osteocytes trapped, they're sitting within pockets, which are lacuna, between lamella of bone. And so we're going to talk a little bit more about those in this lecture. We'll look at osteoblast and osteoclast as well. All right, we want to define this thing called osteoid, whatever that is, because that's going to be important in the bone-making process. And then after we understand what that is, we'll describe the general steps of making bone. All right, so let's get started. So the three cells that we have are osteoblast, osteoclast, and osteocytes. So what I want to bring back is you've seen a slide that looks like this before, right? This is our slide looking back on connective tissue. And remember that all these different connective tissue types, keeping in mind that bone is actually connective tissue, and the native cell of bone is the osteoblast. And what you're looking at here is the osteoblast eventually forms the osteocyte. Now previously, I've said things like fibroblast, fibrocyte, we'll use those terms interchangeably. Chondroblast, chondrocyte, we'll use those terms interchangeably. Osteoblasts, osteocytes, here is where we're going to be a little bit more specific. Really all it means is that osteoblasts will eventually mature, and once they mature, we call them osteocytes. Okay, so all these things that you saw in the osteon previously, when you looked at these osteocytes, there they are, located within these osteons. These osteocytes used to be osteoblasts. Okay, so osteoblasts, they did their thing, and eventually they transformed into osteocytes. Okay, well, what do we need to know about them? Here's what you have to know. Osteoblasts make bone. And obviously we need to talk about what that means to make bone. Well, you know what it means, but I guess the details of it. So osteoblasts make bone. Osteoclasts degrade bone. Okay, osteoclasts will degrade bone. And the note I wrote here is that these cells do not oppose one another. They actually work together. And I know it sounds like they oppose one another because one makes something and the other tears it down, right? Osteoblasts are making bone and osteoclasts will tear it down. But we'll describe that in a second. Again, they don't oppose one another. They do work together, even though they have opposite actions. Osteocytes then are grown-up osteoblasts, and their job then is to maintain bone. Okay, so if you can only say one thing about each of these cells, osteoblasts make bone, osteoclasts degrade bone, and osteocytes maintain bone. Okay, so with that, let's look at this slide. This slide is showing you, again, here's an osteogenic cell. Don't worry about the term so much. It just means it's one of these cells. Let me go back to that picture. Remember how we had these mesenchymal cells, and they go through different steps of differentiation? Well, some of those will differentiate in part, which then becomes a osteoblast, and that cell would be the osteogenic cell. Okay, this is one of those mesenchymal cells, partially differentiated mesenchymal cells. This thing then eventually turns into an osteoblast. And again, what do osteoblasts do? They make bone, and it says here forms bone matrix. Okay, we'll talk about that, but for right now, we just say it makes bone. Eventually, they turn into osteocytes, and you can see that they look a little bit different. Osteocytes then maintain bone tissue, and when you look at this, see these appendages that stick out this way? Again, I'm just going to remind you, we've seen that before. We've seen these appendages kind of stick out through the canaliculi to make contact with one another. And then osteocytes we have here separately. That blue line is just separating out the cell, showing that they're not really connected to these. Osteoclasts, the fancy word is bone resorption. So what does resorption mean? It means you're breaking down bone. All right. So now, what do we mean by these two things? What did I say? What do I mean by these two things actually work together? Well, in my mind, the best thing that I can liken this to is if you've ever seen people make these ice sculptures, it's pretty amazing. And so what I want you to think of is, let's start over here on this upper left corner. Let's think of that there being somebody's job who is to make ice. Okay, so he pours water in a big giant thing and it freezes. All right, so that person's job is to make ice. The osteoblast's job is to make bone, and there it is, your bone. But what you want to understand, and at this point it's not really a novel concept, but once you make something, it doesn't mean you're done and you're finished. There's a refining process. There's a cleaning. Maybe cleaning up is not the right term, but there's a refining process, a continued maturation of that entity. So when you look at this, Look, some amazing artist could say, "Ooh, I see an eagle embedded within here. I just need to reveal him to the world." And how does he do that? He's an osteoclast, and what that artist acts as is an osteoclast, and so he shaves away at the ice. What is he doing? He's degrading bone, but he's not degrading bone for the purpose of destroying bone. His job is not to destroy this chunk of ice. His job is to carve it out into something like beautiful in this case, which is this bird or eagle or whatever it is. And so that's what these guys do. So osteoblasts will make this big chunk of ice, osteoclasts degrade it to make its beautiful form. If you go back here, we talked about this before. How are all these osteons formed? How is this, spongy structure formed, these circumferential lamella? And so to a certain extent, osteoblasts will lay things down, but they're not super duper precise. They lay down a whole bunch of stuff, and then the osteoclast needs to come in. Did I say osteocytes? I meant osteoblast. Osteoblast lay down a whole bunch of bone, and you can think of this almost kind of an amorphous blob of bone, not very well structured into these beautiful osteons and circumferential lamella and stuff like that. Then the osteoclasts come in afterwards and they start chipping and shaving away at stuff. And when they chip and shave away, then we get actually well-formed bone. There are diseases where bone itself is not well-formed. And so in those cases where bone is not well-formed, even if you have enough of it, but it's not laid out in the right way, then those bones are just really not in good shape. Okay, so the architecture of the bone is actually quite important. So that's what I mean by these two things work together. Now, here's an important principle, though. So what is important is to understand that in the big scheme of things, it's not wrong to say that they oppose one another. I'm saying it's just a little bit, it's kind of half the picture. In normal physiology, osteoblasts and osteoclasts work together to make healthy bone. But when one is more active than the other, when there's an imbalance in their roles, typically the way that happens is that when osteoclasts become more active than osteoblasts. Now, whether that's because osteoclasts increase activity that they shouldn't, or it's because osteoblasts decrease activity, my point is there's a mismatch where now there's more osteoclastic activity than osteoblastic activity. In that scenario, your bone will actually degrade. You'll thin out your bones, and we have a disease called osteoporosis, which probably many of you guys have heard of. Probably a lot of people that your friends and family suffer from osteoporosis, which is a thinning out of the bones. More on that a little bit later, not in this video, but in another one. But again, from a certain point of view, yes, it is correct that if one outweighs the other, then you will have unhealthy bone. But it doesn't mean they're enemies. In some ways, you can think of it like if you're a musician and let's say the guitar player in your band versus the drum player in your band, when they play at exactly the right levels with one another, they make beautiful music together. But if the guitar player just starts going nuts and drowns out the drummer, or vice versa, then all of a sudden the music itself is not so beautiful anymore. It doesn't mean it's a competition between the guitar and the drums. It means that you got to have a careful balance. And if there is an imbalance, then you're out of luck. And you can use that example for almost anything team oriented. If there's a dominant player on a team, it's not like that dominant player is competing with his own teammates. If you think of a basketball team, for example, but you know that it's a mismatch. When one player takes all the shots and dribbles the ball all the time, then it's not necessarily good for the sake of the team. It doesn't mean he's competing, though. Okay, so that's how I want you to think about these things. Okay, next thing, then let's talk about the ossification process. So we've covered osteoblasts, you've covered osteoclasts, and I've told you really the only thing you have to know about osteocytes for now is that they maintain bone, and of course the previous information regarding where they live, right? This thing. And so what we need to talk now then is the process of making bone, and we'll introduce this term osteoid. What is osteoid? Well, actually before that, let's talk about ossification. Ossification is the fancy word for how we make bone. Very simply, we're going to describe this as a two-step process. So what is it? Step number one, osteoblasts make bone. Remember that? Osteoblasts make this thing called osteoid. Well, now the question let's answer is, what is osteoid? Osteoid are protein fibers and ground substance together. So remember, coming back to connective tissue, what is connective tissue? They're made up of cells, protein fibers, and ground substance. Now we know the cell type that makes the bone, that's the osteoblast. And now we know, well, we don't know yet, but the protein fibers are collagen. There's some others, but collagen is the main one, and then the ground substance. So the protein fibers and ground substance together are referred to as osteoid. Okay. The next thing that happens is mineralization, which is precipitation of calcium salts to form this thing called hydroxyapatite. So what I want you to see, mineralization is when you end up depositing calcium on top of this osteoid framework. And the mineralization is what's going to make bones hard. All right, now there's a few terms that are used out there commonly in a lot of different textbooks or YouTube videos and things like that. And so I want to clarify some of these things. These are very similar terms, but they do mean slightly different things. So ossification, what is ossification? Ossification is the process of making bone. I had that on the previous slide. Ossification is how we make bone. So that is ossification. Now, within ossification, there are these three words: precipitation, mineralization, calcification. Again, these all sound really, really similar. Well, let's talk about these. What does precipitation mean? Precipitation is just a term that is this. It's a process where dissolved materials come out of solution. Imagine for a second that, let's say you have a cup of water and you pour it in like 3 teaspoons of salt, and you see the salt. It's this white crystalline structure. You dump it into the water, stir it with a spoon, and you, as you guys know from experience, you don't see the salt anymore. It gets dissolved. And now, because we've had chemistry, you know what that looks like, right? When the water molecules kind of cover, right, all these cations and anions. So it gets dissolved. Now imagine that you could snap your fingers, and when you snap your fingers and you're looking at that water, all of a sudden that salt reforms right before your very eyes. So instead of being dissolved, it reverses that process and reforms that crystalline structure. That process, where the dissolved salt, in this case, comes out of solution, meaning that it reforms as that solid particle that I could almost scoop back out with a spoon, that is called precipitation. That's precipitation in this context. I mean, in a more generic context, precipitation means it's going to rain, right? That's the rain or snow or whatever we have outside. But this is what we mean here. Now, what does mineralization mean? Mineralization is a process where that inorganic stuff, in this case, it's going to be calcium, because calcium was dissolved in our ground substance. Then there's a precipitation process that occurs where all of a sudden that dissolved calcium forms these crystalline structures, these crystal structures. Now, then what happens with those crystal structures is they get deposited upon our organic matrix. What is the organic matrix? It's the osteoid. It's the collagen ground substance thing. And when that deposit happens, we call that mineralization. Okay, so precipitation occurs and then mineralization. So a lot of times casually, sometimes we use the terms interchangeably, but again, precipitation means those dissolved calciums swimming around in the ground substance will actually form crystal structures, and then mineralization is when they get deposited upon that organic matrix. And it's a seamless thing. It happens all together at once. What is calcification then? Calcification is specifically mineralization that occurs when it involves calcium. That's it. That's all it means. So calcium is the primary mineral that's used here in the bones, and so sometimes mineralization, calcification, it's probably more appropriate to use these two terms interchangeably, as long as you understand that they mean slightly different things. In other contexts, mineralizations may not involve calcium. It may involve some other mineral, but in the bone, which is where we're at right now, it is calcification, which is a specific type of mineralization. So let's take a look at that. If we take a look at this picture, here's what we have. This is collagen. And remember what collagen is like. Remember, this is kind of rope-like, and it allows some flexibility with the bones. This is the organic matter. And so what ends up happening then is that I put this red arrow here to say precipitation now occurs. And what is precipitation? All these little purple crystals of calcium form. Calcium is present here. You just can't see it. It's dissolved. Just like salt dissolved in water. You can't see it, but it's swimming around everywhere here. And then when precipitation occurs, they start forming these crystalline structures. Then they get deposited on top of all these structures, and it looks something more like this, and now it has been mineralized. These things that again arranged in a certain way, and voila, now we have bone. So mineralization, again, is that process where inorganic stuff, inorganic in this case means the calcium salts, these things now deposit to form something like this. Okay? Now, there's two types of ossification that I just want to name out. And so those are intramembranous ossification and endochondral ossification. So I just want to name those. We'll talk about those later. But again, what was our learning objectives? Our learning objectives were to describe the three roles, which we did. We described osteoid, who makes it. Osteoblasts make it. What is it? Collagen fibers and ground substance. And then we described the general steps of making bone. And those general steps of making bone are Osteoblasts make osteoid, and then we see mineralization, which occurs after precipitation of calcium salts to form this thing called hydroxyapatite. And so this is what I need you to know. This stuff right over here is what I need you to know for this third learning objectives, okay, the general steps of making bone. We probably should include here these terms as one of your learning objectives as well. I just assumed that these terms would be learned as part of this third learning objective. So if you want to specifically write that out here, feel free and go ahead and do that. Okay, that'll wrap it up for this video.